Welcome to Yonder Dynamics. We're a student-run robotics organization from the University of California, San Diego, and we'll be participating in the University Rover Challenge of 2021. Due to COVID-19, our team has been completely restricted from accessing our rover physically, but despite this, we're still really excited to show you all the improvements that we've made and plan to implement once we get back in person.
For the science mission, our team has designed a modular drilling system consisting of a 2-inch auger mounted on a linear track actuator. The drill and auger were tested on hard rocky soil to simulate MDRS conditions. The soil flows out of the top of the auger and is collected in sample cups in the carousel. The sample carousel uses a servo motor to cycle through each collection cup, allowing us to sample 6 locations at a time. To test for extant life, the cups will be preloaded with a nutrient broth to stimulate microbial growth. Arduino turbidity sensors are attached to the bottom of each cup to measure the turbidity over time. To test for extinct life, we're employing an onboard Raman spectrometer to look for trace signatures of carotenoids in our samples. Carotenoids have been theorized to be a byproduct of cyanobacteria radiation shielding and repair mechanisms, so evidence of carotenoids in a sample might be an indication of Martian life. New this year, we have developed an ATP detection assay to confirm the presence of viable but non-culturable extant life. This assay will be integrated into our science module once we are back in person.
The suspension of the rover is a rocker bogie system with 1/5 scale RC car rear shock absorbers to allow traversal of steep and rocky slopes. There are 2 PlayStation cameras attached to the arm to facilitate the equipment servicing and retrieval tasks, and 1 camera attached to the front of the rover for navigation. Each rubber tire is powered by a geared-down 775 Pro motor with an output of 106.2 Nm each, allowing it to get through sandy and rocky terrain. The chassis is made of lightweight carbon fiber and 6061 aluminum tubing, and the arm is a combination of carbon fiber tubing, Delrin, and machined aluminum parts, ensuring proper resilience for MDRS conditions while remaining under the weight limit. By using 3D printed material for much of the hand and wrist, we were able to make quick changes to the design, and have tested various finger shapes to increase grip strength. This year, we have improved upon our previous arm design while under quarantine. This includes revising our shoulder joint, designing new wheel hubs, and a complete overhaul of the hand design. We are excited to implement these improvements as soon as we resume in-person operations.
To overcome the challenges of remote development, this year the software team focused on simulation and exploration. We rebuilt our entire software stack in Docker so that every team member can make progress without access to the rover. With only 2 commands, anyone can download and start a full simulation of the rover. Controls are smooth, intuitive, and accessible through a web interface that enables any member of the team to use the rover and monitor the onboard systems. We incorporate magic filtering to fuse our sensor data for autonomous navigation and path following. We have built and trained our own YOLO-based tiling method for AR tag detection and tested it with thousands of real images. Our exploration stack has been trialed in an immersive, randomly generated ROS gazebo simulation of a URC-like environment. We capture depth maps through a Z stereo camera and run our SLAM methods on an NVIDIA Xavier. Our exploration method generates random paths and then picks the optimal one for exploring an area and finding the QR tag. We have built a precise inverse kinematics model of our arm for easy and accurate fine motor control.
We have updated the electrical system from previous years to improve reliability and have extensively tested our systems. Our new system separates 5V and 12V electronics onto 2 layers to improve organization and safety. Several redundant systems to monitor battery voltages have been added to ensure visibility of the rover status. For communication, we have tested our antenna successfully up to 1 kilometer away. During our remote work phase, we designed several printed circuit boards to consolidate our wiring and support new features on the rover. These include the rover's RGB LED signal lights, motorized panning of the rover's 3D camera, and more sophisticated cell-by-cell battery monitoring. Additionally, better documentation of the electrical system has allowed us to update the rover's electrical design for improved modularity and robustness.
We hope you enjoyed watching what our rover can do. Thank you for watching, and we hope to see you at the 2021 URC Finals.